doors, and I'll show you the inside of the pump. Okay, here we have the 100 horsepower motor coming through a coupling into the A11V pump, hydraulic pump. The first pump is for the piston pump upstairs. The second pump is for the screw feeder. And then you have your recycle oil and stroke pump on the very end down there. It de-strokes the pumps and keeps oil circulating in the tank and throughout the system. We have our drip lines coming down from our KSP upstairs and from the screw feeder upstairs. We have C and D lines going to the screw feeder upstairs. We have our two primary pump hydraulic lines feeding the KSP upstairs. We have our temperature gauge and oil fill gauge right here. Right now we've been running for approximately 4 hours and we're at about 70 degrees Fahrenheit or 30 degrees C. Oil line is right up to the top. It's right where we want to see it. We have an access and clean out cover on top of the tank. We have a filter fill cap. Right underneath this cover is the wiring for the level gauge inside the tank. It's just a simple float gauge. Right here is our loop oil filter and the pressure gauge associated with it. This pressure gauge is set at approximately 20 psi, and it's just a warning pressure to tell you to change your oil filter when it gets dirty. We have our sludge pump pressure gauge. As you can see right now, we're running at approximately 1500 psi hydraulic pressure, just slightly under. It's fluctuating somewhat, and that is equating to the 600 psi pipeline that we were witnessing earlier on the HMI. Now, if you watch how this pressure gauge is working, right now it's pumping, about to shift. There, it shifted with about a 500 psi spike, drop down and right back up to 1500 or 1450 psi. We come down a little lower, we'll see the screw feeder pressure, which is running at about 1100 psi continuous. Right here we have our oil cooling water. It is non-potable water. It's reuse water. This side's a little cooler than the outlet. The outlet, it's doing its job. It's cooling the water, or the oil, excuse me. Around the corner, we have our high pressure gauge, high oil pressure gauge. You can see we're set at about 1950 PSI with a reset of 1850. And that is, go around to the other side of the unit over here. Show you the other oil filter. This is the conditioning oil filter, and right here we have a telltale button. Right now it is green. When you start up, if that button pops up and it's red, let the oil warm for 10-15 minutes. Press the reset button on it, and then it should stay green. If it doesn't stay green when you push the button, then you'll know you need to replace that filter. One more thing to show you. Load solenoid. Right under here is load solenoid. You can see the lighted plug. So you know you got power going to the load solenoid. Now if for whatever reason that light does not light, or you know that the load solenoid did not function properly, you can reach up with either a Phillips screwdriver or an Allen wrench and push in on the end of this solenoid and activate that load solenoid to get you through an emergency, to empty out a hopper or empty out the pump. A very important thing to remember in emergency. Now we'll go upstairs to the hydraulic, or the KSP, and the screw feeder. Thank you. All right, we're coming up on the KSP 25. So named because it puts out 25 liters of sludge per stroke. Here we have associated lines that we saw downstairs coming off the hydraulic power pack. We have lines A and B. We have our drip line F. We have our forward and reversing solenoids. In normal operation, it's always in the forward position. In maintenance mode, we can alternate between forward and reverse by the flip of a switch. Here we have one of the two throttle check valves, or excuse me, throttle valves. These we adjust. It's a part of the sludge flow measuring, and we adjust these to get optimum performance out of the pump. This area is the water box. Some people call it a wash box, but it is the water box. It serves a couple of different purposes. One is to clean and lubricate the cylinder rods as they're passing back and forth through the water box into the hydraulic cylinders. Another purpose is to cool and lubricate the rubber rams, the material piston rams, which are going back and forth in the material pistons. The other the other purpose for the water box is for maintenance purposes, so that if you see a residue of oil building on the water, you know that your chevron packings right inside this area need to be replaced. If you see sludge building up, abnormal amount of sludge building up in the water between shifts, you'll know that your material cylinder rams will need to be replaced. Be absolutely sure to fill that water box before operation and to empty the water box when you're done operating. If you leave water in the water box when you're done operating, the oil and the water cool at different levels, and it can create a vacuum and suck water into the hydraulic oil, contaminating your oil. So always be sure to drain the water box when you're done operating. As we come down the line, we come to the poppet housing. These are your two suction poppets. These take in what the screw feeder sends it. They alternately pull or open and close. So if this upper cylinder is sucking back, this poppet will be open. This poppet will be closed. That cylinder will be pushing out the material it had received before. At the same time, this pressure poppet, which is right here, this will be closed, and the sludge will be forcing this lower pressure poppet open, sending the sludge down the pipeline and out to the incinerator. The shifting you hear is the poppets shifting. It'll reverse the direction. The lower cylinder will be pulling in the material as the screw feeder forces it in, and the upper cylinder will be pushing it out the opposite pipeline. Now on this particular pipeline we have control valves, ball valves that can control the direction that we send the material. Right now we're feeding all the material into the north pipeline, which is the one up against the wall. Otherwise they could be sending it down two separate pipelines at the same time. Over here we have our pipeline pressure gauges that tells us what our pressure is reading. Keep in mind that these gauges you need to multiply that value by 10. So we're actually reading 540 psi, not 54. These are your mag pickups, magnetic proximity switches, proximity sensors. They are telling me what location the piston inside this cylinder is. And that also determines in our sludge flow measuring. So we know when the poppet opens, how much material has been put into the material pistons by the way, the timing of both these two different proximity sensors. These are your throttle check valves. Right now I have them set at 1 1/3 turn open. Always check to make sure that they are set at approximately that position. That's the optimum position for this particular operation right now. It may vary and maintenance will take care of those settings. Some things to look at. You want to make sure when you're doing your walk around check you're not getting sludge coming out of these weep holes and you're not getting oil coming out of these. If you're getting oil, it means your chevrons are going bad. If you're getting sludge, it means your poppet valve seals are going bad. Right over here, we're switching over to the screw feeder now. We have our transition pressure gauge. Remember talking about that earlier. Okay, that is when we're running in pressure mode, that is the gauge that is telling the computer what the pressure is in this housing being fed. And I will switch over to the screw feeder. Okay, here at the screw feeder we have a automatic greaser. This greaser will cycle approximately every 15 minutes for about a minute and a half, 2 minutes, maybe 3. If you want to check, if you walk by and you don't see the little dash line, if it isn't moving, it's just in between cycles. If you want to make sure the unit is functioning, push and hold the green button until you see the little green asterisk moving around, and you'll know that the pump is functioning. You'll also see a little paddle going around the pump. See, it's coming. There it goes. And you'll know that the pump is pumping grease into your 2 hanger bearings. This is where the front of your screws are in a bearing. And these are the screws inside. Right now, that's a pretty good flow rate going on. We don't have too big of a roll happening. We know we're getting as good a filling efficiency as we can possibly get, and we're not overflowing the tub. So that is a very good fill rate right now. It could be a little bit less. I wouldn't want to see it a lot more. Here's the gearbox and drive end of the screw feeder. Corresponding C and D lines. Your forward reversing lever, also neutral, forward reverse neutral. It's got a tag right below it. Tells you which direction you're in. Down here you have packing glands. And you want to make sure that you're not getting too much sludge coming out of here and just a little bit of grease coming out. If you're getting sludge, you need to tighten these little 3/4 bolts. They're 1/2-inch bolts, but a 3/4 inch, 19 millimeter, until you pull this, draw the pressure gland in to seal off that sludge from weeping out. You don't want sludge coming out and impacting. There's a shaft seal here on your gearbox, so make sure you clean this area out, hose it out after shifts, so that the sludge can't get hydraulically pressed into the gearbox. And here you have a sight glass oil level for your gear lube. You want to make sure that that oil level stays at about the midway point. Again, make sure you don't have any hoses touching each other so they don't scrape. If they're touching each other, you need to reorient them so that they don't. Right now we don't have any hoses touching, so we won't have any scrapes. As you do your walk-arounds, checking the equipment,